Good evening, everyone, and thank you for joining us today. My name is Nishtha, and I work with the Word Lab at IIHS. The Indian Institute for Human Settlements, for those of you who don't know, is a national education institution committed to the equitable, sustainable, and efficient transformation of Indian settlements. Do look up our website. Welcome again to Public Texts with Mala Radhakrishnan and Siddharth Kankaria. So this series, the Public Text series, is a curated set of conversations where we invite diverse authors to talk about their work. It's hosted by the Word Lab and the IHS Library, which is a public reference library. If you'd like to receive updates about upcoming sessions, do sign up using the link in your chat box. Quick housekeeping rules. Those of you who've joined us on Zoom, please keep your mics on mute and your videos switched off. If you have any questions for the author or Siddharth at any point, just put them in the chat box and we'll take them up when we do Q&A later. And for those of you who are joining us on Facebook, just in case our Facebook Live goes off, there's a Zoom link, which is a pinned post that you can join us with. Finally, it's my pleasure to introduce Mala Radhakrishnan and Siddharth Kankaria, who will discuss writing about science in verse. Science and poetry don't often come together, so we're all really looking forward to this session. Quick intros to both of them. Mala Radhakrishnan is the director of the biochemistry program and an associate professor of chemistry at Wellesley College in Massachusetts, USA. In addition to teaching a variety of courses, she oversees a computational biophysical chemistry research lab whose aim is to develop and apply models to better understand dynamic biomolecular interactions. She's also committed to creative science communication and humanizing science, and towards these ends has written 2 full-length poetry books that engage readers with concepts in chemistry through humor, personification, and themes in everyday life. In addition to science and poetry, she enjoys music and spending time with her family. Siddharth Kankaria, who will be moderating this session, is a science communication practitioner with a background in biology and science communication. He currently works as the outreach manager at the Simons Center at NCBS, and in his spare time runs a journal club called SciComm-Sci, engaging with the science of science communication. Siddharth is keenly interested in facilitating dialogues for bridging the gap between science communication research and practice, researching evidence-based science communication practices, and developing more effective ways of engaging society with science. Hope you enjoy the conversation. Thank you so much once again, Mala and Siddharth, for being part of Public Text. Over to you, Siddharth.
Hello, everyone. Thank you so much, Nishtha, for those lovely introductions. A very good evening to everyone, and thank you so much for joining us today for this session of Public Text with Mala Radhakrishnan and me. We live in a world where science and art are often perceived as being distinct from each other. But in reality, these distinctions are much more artificial than we realize. And there's so much that science and poetry share in common and can learn from each other. For instance, both science and poetry developed as a way to make sense of the world around us and share it with others. They were both motivated by an urge to realize and reveal the secrets of nature. Moreover, both science and poetry extensively rely on using metaphors to paint a picture of the world around us, often with the most intricate of details. It is therefore not surprising that science and poetry tend to fertilize each other. Charles Darwin himself carried the works of Milton throughout his expeditions in South America, and his poetic influences definitely manifested years later in his seminal work on the origin of species. Today's session is an attempt to explore the intersection between science and poetry based on Mala's experiences of using poetry in various ways. Mala has performed her poems in poetry slams, used poetry to teach science to her students, but also uses it to share her insights and life experiences, both as a scientist and a mother. And we can all be grateful for all the wonderful chemistry puns that are going to be coming our way today. So our conversation today promises to be a freewheeling conversation about all things science poetry, including Mala's 2 books on chemical verse, her experiences of writing and performing poetry, as well as discussing how the medium of poetry can be a great equalizer in talking to people of different backgrounds and expertises. We'll also be taking questions, as Nishtha already pointed out, so please feel free to share your questions in the chat box. Without any further ado, I would like to invite Mala to tell us a little bit more about how did she begin writing science poetry and what has been her journey so far. Mala.
Thank you so much, Siddharth, and thank you to IIHS for inviting me and for Public Texts. This is really great, and I'm excited to be here. Yeah, so my journey into writing chemistry poetry was somewhat nonlinear. I started out, really excited by chemistry. And after my undergraduate work, I actually taught high school for a couple of years. And just through teaching, I realized that, to really make science engaging, and make it more relatable, telling stories, personifying the molecules, because really, as we know, what's going on is atoms are really just bonding, they're forming relationships, they're breaking up, right? And so what's happening on a molecular level is, as I like to say, is like a soap opera, right? It's sort of like, it's very dramatic, right? And if we can personify this and tell stories about it, we can make it more relatable. And so that's sort of the approach I took when teaching high school. And I would often have students also tell stories. Can you personify this kind of event? Can you come up with an analogy to describe this? So uh, then what happened was, and I don't remember exactly the timeline, but at some point when I was teaching high school, one of my friends took me to a poetry slam. And this is a venue that is a really historic venue in Massachusetts. It's actually geographically equidistant on this road that connects Harvard and MIT. And they have a weekly poetry slam. And I had never really thought about poetry before. I had never really gotten involved with it. And so just I had sort of in my mind what sort of slam poetry was about, what spoken word poetry was about. And my sense was that it was, people always sort of talked about or wrote poems about the same kinds of things, maybe public events or, human relationships, but there wasn't necessarily a lot of sort of other kinds of topics that people would write poems about. And when I listened to the diversity of the kinds of things that people wrote about, I realized, wow, poetry really can be a way to express or communicate anything. And so I was really inspired. I went to listen for a few weeks, and then finally I got up the nerve to, I got over the activation energy barrier, so to speak, of sort of reading my own poem. And so I did, and it was kind of catalytic. After that, I got really hooked, and then I realized, well, what I can do is start to tell some of the stories that I tell about these molecules in verse. Maybe that's a more enticing, when you write things in sort of rhyming poetry, it kind of makes it seem a little more um, like, almost like reminds you of your childhood, right? And so it makes these sort of sophisticated, rigorous concepts seem more attainable, understandable, familiar. So when I finished teaching high school, the last day they were going to actually destroy the building. They were going to renovate it, and so I got permission to have my students paint murals across the walls of the classrooms, and it was really wonderful to see. They wrote almost their own stories of, atoms and molecules coming together, and it was all chemically accurate. And from that, I also got kind of inspired to turn some of these kinds of stories into verse.
You mentioned that you've used poetry both for teaching high school students and as well as performed it in poetry slams. Did you notice any difference between the kind of audiences and how they reacted to your poetry? And did you have to make any changes to your poems before performing them?
Yeah, absolutely. I think the audience is really interesting. So the first few poems I read, were exclusively in this poetry slam venue, which was essentially a bar, right? And so there the audience was generally not going to be people who were, chemists or scientists. And so those poems tended to be more about sort of using chemical language, but using a lot of it in maybe a little bit more of a risque, like, atoms getting together in a more risque way, let's say. And there was a lot of humor. I think all my poems tend to have humor in them, but these were more really about getting the audience reaction. But then at some point I had someone from that bar come up to me after one of my readings and saying, I wish I had learned chemistry like this. I really, the concepts now really make sense. And that's when I realized, I can actually maybe start to write more strategically with the aim of maybe taking certain concepts that students might find confusing as they embark on chemistry, and trying to come up with a storyline to make it clearer. And so then I started to write more strategically about topics in a more pedagogical way. And so I would take a concept that I thought was kind of confusing, and I'd say, how could I make this relatable? And so when I write for a student audience, sorry, I would say that yes, I definitely am thinking more, how can I get these concepts clear in a humorous way? But also, thinking about the audience in mind. How do I make the analogy I use maybe as inclusive as possible? How do I, make it appropriate for certain age groups? That kinds of things, you have to think about. So the audience definitely matters. And in fact, some of my poems have gone in a high school chemistry textbook. And for that project, we had to almost rewrite the entire poem, right? Because an atom cannot walk into a bar, right? An atom had to walk onto the scene. And so they had to change the rhymes. And I mean, I'm in two minds about it. In one way, I feel like sometimes having that element of a little bit of, another pun, the element of something that's maybe a little bit more humorous or a little more risque could make it in some ways more relatable to people, more memorable, and sometimes making analogy that's a little more, I don't know, not as bold or something, might be a little less effective. So you have to find the right balance, I guess, in sort of coming up with making things relatable.
Right. That's really interesting. So if I can quote back a couplet that you have written in your book, teachers as catalysts, somewhat misleading, forever they are changed after each classroom meeting. So I also want to know, I mean, you've shared your experiences of, what you've been through. How have the students reacted, and have they come back and told you that, that they sort of like this approach of learning concepts in chemistry and science? What has their reactions and their feedback been?
Yeah, I mean, generally, they really enjoy hearing the poems in class. Generally, it's a great way to sort of cap off a lesson, especially with some of the longer narrative poems from my first book. It brings a lot of things together, and actually, I've had students write poems themselves, and some of the things they come up with are really quite amazing. Occasionally, I'll have a student that will tell me, so many of your analogies are about, let's say, human relationships, and that I don't necessarily, that doesn't resonate with me. And so again, I think coming up with a big diversity of ways to explain things, diversity for some of the analogies or some of the narrative stories would be really good. And so I've really tried to broaden and think about what are all different ways that I could sort of make these stories relatable, make these concepts relatable, to be very inclusive.
That's great. Do you think poetry has allowed you to kind of get into the nuances of certain scientific concepts in a more better way, or has it enabled you to kind of talk about more abstract concepts in science in a more tangible way? Has poetry been helpful as a medium in that regard?
I think it can. I almost think in my asking students to write poems, it almost brings about their misconceptions more, or even having them use analogies. So sometimes I'll ask students, can you, let's suppose you had to explain the concept of an orbital, so an electron wave function, basically, an orbital to a fifth grader, right? How would you describe it? So now they have to use everyday language. They have to try to relate it to something that a fifth grader might be, familiar with. And in reading their responses, it becomes immediately clear if they're misunderstanding a concept. And so I often find it a really great way to just sort of get a sense of how well people are understanding things, and also to check my own understanding. I think it provides a real great opportunity. Now it does have constraints, but the nice thing about poetry is I write pretty constrained poetry in the sense that it usually rhymes and it usually has some tetrameter rhythm. But poetry as a general form is, you can make up the rules, right? It's really a very inclusive medium in that way. And so it's up to you to decide how you want to use it. And that way, I think it's more liberating than prose. It can be more brief, which is a nice thing as well. And it also is subject to many different ways of interpretation, which also involves the reader a lot more. The reader might have a different experience that might relate to it in a special or unique way.
Great. Before we proceed, would you like to read out a few of your couplets? Just
Sure.
so we have some context.
Yeah, so these are from my most recent book, Thinking Periodically. And this book is essentially a set of brief about a few hundred couplets. So they're all very, very quick poems. So I'll just read about a dozen or 15 of them. And a couple of them might need a little bit of explanation beforehand. Life is like chem, because the goal's to be able to bond well with others so we can be stable. When a product proclaims that it's chemical free, then it's just empty space. Don't you agree? As a chemist, I feel such dissatisfaction when one of my poems yields no reaction. Now this one's about the second law of thermodynamics, which is all about entropy or disorder. The second law, to prove it, I'd say just look at my hair at the end of the day. And this sort of ties entropy into having kids, because there's a lot of, randomness. And you want to see entropy's strength in the making? Show toddlers a leaf pile you spent all day raking. A toddler and fluorine are worth our comparing, both small, reactive, and not good at sharing. Kids are like electrons, essential yet small, and I simply don't get their behavior at all. And this is about sort of the everyday stresses in life. We are like gases. While things seem ideal, the chaos you see right up close is what's real. This is about sort of being creative. Creativity is much like a gas in its measure. It shrinks when its system is under great pressure. Constructive critique, it reminds me of light. It only excites if the frequency's right. And these last few are about the intersection of arts and chemistry. Be a poet or chemist, and don't feel inhibited. Both word space and chemical space are unlimited. Though more years to our life has science been giving, humanities make all these years worth living. When art meets science, it's truly phenomenal. Let us stop thinking that they are orthogonal. If atoms are notes and molecules phrases, then chemistry's music that truly amazes. The reactant in chemistry that is most relevant is not what we think, it's the human element. Chemistry, poetry, wonderful things, both capture the beauty that every day brings. And then this last one was sort of the dedication in the book to my daughter. Like a magical photon so boldly behaves, be bright, be quick, excite, make waves.
Wonderful. Thank you so much for reciting those. Picking up on the last couplet that you shared, let's talk about the role of personification and using anthropomorphism in science poetry. So you often use, you attribute human characteristics to objects in science or scientific objects and sort of draw parallels between the two. And so how do you think this enables you to kind of write science poetry, and what's the role of personification in your work?
I think it's a two-way street. So what I mean by that is, in one sense, by personifying things, of course, we make concepts in chemistry seem more relatable, right? We all feel emotions. We all have relationships with other people, whether friends or enemies, or, we all understand what it means to have certain emotions. And as long as we're very, very clear that, we're not necessarily saying, and I tell my students this sometimes, atoms don't actually talk, and they might not, they probably aren't feeling these feelings, right? But to understand, it really helps students, find their own ways to understand and their own perspectives, bring their own perspectives into how they understand these concepts. Because at the end of the day, the models that we teach in chemistry are things we make up, right? We came up with Lewis structures. We came up with quantum mechanics. The atoms and molecules themselves, the real world out there is doing what it's doing, but we create these models, and in some sense they're fictional to be able to try and make sense of the world. And some describe things quantitatively, but you can think of personification or an analogy as some sort of mental model as well. It allows someone to create an understanding of the world around them, just like quantum mechanics, maybe not as quantitative, but maybe brings some other sort of way of understanding the same material. So in that way, that's sort of one direction. But the other direction that I think is equally important is I often feel like the sort of when people think about a scientist or they think about science in general, they think about something that's very removed from human emotion or just humanity in general. And this is evident when, when you see, it's evident when you read a scientific paper, right? Oftentimes these are written in passive voice. The journey that the scientist took to get to the answer is sort of taken out of the picture. It's meant to be reproducible, but sort of another way that science sort of views reproducibility is sort of impersonality, right? Just remove the person's experience from whatever the discovery is. And I think that what that does is a real disservice to science, because it makes people think that science isn't an exciting thing. Science isn't something that we should feel emotions while doing. It isn't something that we should be excited or struggling or, sometimes feel like we failed in, right? And what that does is it also makes science feel less inclusive to everybody. Some people might not see themselves as being a cutout or being that science is for them, because it does seem so like, removed from these sorts of emotions. And so I think it's a two-way street. I think using personification to try to understand chemistry reminds us that we created science, right? And science is a human endeavor, and it's always going to be a human endeavor. And so we have to bring ourselves into it. It's a creative endeavor as well, right? And sometimes people forget that science really is creative.
Right. Thank you so much. I think it's really important to kind of humanize scientists and sort of also talk about the process of science, and that humans can make mistakes and they have emotions. And so I think your point about personification also helping humanize scientists and sort of changing the image of scientists and how people perceive scientists, I think that's a really important point. If I could just give an example, there are a lot of scientists who have used poetry or have written poetry in the past. For example, J.J. Thomson, the person who discovered the electron, also wrote a lot of poetry, and it's available on the internet if anybody wants to look up. Right. So carrying forward on the concept or on the theme of personification, do you also find? Let's talk about metaphors. I mean, and imagery, for example. So metaphor is something that both poetry and science use for explaining concepts or for better understanding concepts. Do you see, yourself using a lot of metaphors in your poetry?
I think I do. I mean, a lot of the metaphors I do use are, again, relating to personal experience or to, maybe general humanity experience as a whole. But I do think so. I do think it's important when, especially from a pedagogical standpoint, when you're teaching or in the classroom, to talk about, when you do use analogy and metaphor, especially, to talk about the limitations that they also, like every model has limitations, right? Whether it's quantum mechanics or a simple metaphor, but sort of engaging in what those are, again, because what that does is it helps you address any misconceptions. It helps you understand and dig deeper into what the concepts are. But I definitely do. And it's, in fact, when I live my everyday life, oftentimes what motivates me for these couplets, the idea or the spirit behind these couplets is that they're written spontaneously, right? They evolved out of Twitter, the sense that I would be going about my day and then something would just happen. I was like, oh, this is just like an activation energy barrier, or this is just like, so in that sense, I see the metaphor there, right? Or the analogy, and so I would immediately come up with some sort of couplet to sort of describe it. And so it's about making those connections. And I think making those connections is a way to deepen someone's understanding.
Great. Should we have another recital of a slightly longer piece, maybe this time?
Sure. The two books. So the first book are longer poems, and the idea is to use everyday life, the language of everyday life and personification to explain concepts in chemistry. And these are based on a lot of the stories that I would tell, as a teacher. The second book, which I mainly came after having kids when I didn't have as much time, was using chemistry language, the language of chemistry, to talk about everyday life. So I tried to practice both because I think there's value in doing both. And again, it sort of solidifies that two-way street. So this is a poem about quantum mechanics, but it's about the basic idea behind quantum mechanics, which is that you have these, every molecular system or atom, in this case hydrogen, has these quantized energy levels that electrons or whatever sort of part of the system you're studying are allowed to be in, okay? So they can't have any energy value, they're just these quantized ones. And when you shine light at this system, in this case hydrogen, if the light's energy, the photon, which is a particle of light, its energy matches the energy spacing between a pair of levels, you can excite that particular system. So you can excite hydrogen. And so therefore, hydrogen will only take in light at these certain quantized frequencies. Okay, this is called guiding light. Hello there, good doctor. My name is Leon, emitted last night by an atom of neon. Because I am light, I've got reason to rave, for I can exist as both particle and wave. Before I was dating a pretty blue photon, but we weren't on the same wavelength, and so I rode on at 300 million meters per second, a much faster speed than you ever could reckon. Whenever my friends ask me, hey Leon, what's new? I say 5 times 10 to the 14th hertz. And you? But I envy the violets, the UV, the blue, because they have more energy, much more than I do. But I'll get to the point, Doc, because you're in a rush. My problem is simple. I've got a huge crush on an atom whose life I could make a lot brighter if only she'd let in my light to excite her. Her name is hydrogen, the simplest of matter. If I try her at best, I rally scatter. What's that you say? It's useless to panic? It all has to do with quantum mechanics? Her energy values, you say, are quantized, like rungs, with spacing specifically sized, and only those photons whose ease match a spacing can get her electronic heart to start racing? So if I were red or purple or cyan, then I could get her electron to buy in, but pitiful me, my color is yellow. I guess I can never be named as her fellow. And even those colors would pleasure her not unless she already was awfully hot. At 300 Kelvin, she's in her ground state, and only UV light can make her upgrade. I hate quantum M. It limits my hopes to a handful of mates and some isotopes. Now, what's that you say? It's really quite cool? An analytically useful tool? As each type of atom has unique spaces, you shoot it with light, see which news it erases. So all atom types have their own special spectrum, and whenever they're present, you know to expect them. So look at the light from a distant star and you know what atoms it has from afar. Wow, I guess my case has been lost because the benefits clearly outweigh all the costs. I'll stay yellow and mellow, blue and weary, green with envy, cyan and weary. Goodbye, my doc. I guess we agree on the fact that my E is still perfect for neon. For all of you humans out there, think twice before you complain that your prospects aren't nice. Although it seems challenging finding your mate, at least you don't need physics to resonate.
Yeah, thank you for that. I don't think I would have paid attention to a lot of the chemical concepts, were it not for the fact that it was related to something I can really relate to, which is dating or finding someone to date. So I think that's a great way of sort of making people look up and pay attention. I also want to ask you about how is what's the back and forth between your personal life and the poetry. I think you alluded to it a little bit before you started this poem, but I think how do you think your everyday life experiences, influences your poetry and vice versa?
I mean, I think it's pretty extraordinary, actually. Well, so in the second book, it's all based on, things happening in my life. So it's kind of called Thinking Periodically. The periodically has a lot of meanings. It's the ups and downs of life. It's sort of how, the days kind of repeat after a while. So, sometimes it's about the kids, sometimes it's about work and stress or the messy house and, being a chemist. So, in that book, it's very clear, like, it would literally be something I'm doing. And then I'm just like, whoa, this reminds me of this chemical concept. In the first book, I would say it was a two-way street. I tell my students there's one of the poems in the first book I wrote was about an ion. It was called The Ion Without a Name. And this ion meets another ion on a bus, okay? And the only reason this happened on a bus is because it rhymes with the word anonymous. And about a week after I wrote that poem, I met who was going to become my future husband on a bus. So I thought that was just kind of neat. It was where you write something first and then it almost like came, I mean, literally kind of came true. But sometimes, you know, if I'm, certainly my mood will affect sort of the whether the poem is a happy story or not a happy story, especially in the narrative ones. But sometimes I try to pick a story, well, I always try to pick a story that will get the scientific concept clear, but whether or not it has a happy ending is often about sort of my general mood at the time.
Right, thanks. I would like to read out 3 of your couplets from your book, Thinking Periodically, and I'll ask you a question after that. So, first one is social media followers as well. They are like our own personal salvation shell, right? The second one's life's the best match for spectroscopy by far. By seeing what excites us, we learn who we are. And the last one's likes dissolve likes can describe how we mix. Cause like molecules, we tend to hang out in cliques. Now, the common theme across all 3 of them are that they're sort of imparting a life lesson. So, is that something that is intentional? Is it born out of your own life experiences, or even, you know, as a parent, your experiences sort of, you know, influence this poetry? So, would you like to sort of comment on this?
Yeah, I mean, I think that we can learn a lot about sort of life. We can use some of the sort of chemical concepts to try to, you know, become better people. Again, we are, this is a human endeavor, but we can try to extract things about, so this idea that likes dissolve likes, in sort of the video that you showed in advance about the sugar dissolving in water, that is, molecules like to hang out, polar molecules like to hang out with other polar molecules, right? And non-polars like to hang out with and I wish that wouldn't, you know, in some sense, like that's how chemistry works, but that doesn't necessarily mean that's how it has to work with humans. And so I actually have a poem in my first book that that talks about how I talk about the process of dissolving things and how in society we shouldn't do that. And if it ends with, you know, if we fight these cliques, so to speak, then many issues we would solve, and then most of our problems would simply dissolve, right? Thinking about dissolving and sort of the other way. And so, yeah, I think that, you know, again, in trying to think about right now, with the world being as politicized as it is, and you know, so many different issues going on, I often find myself thinking about, you know, how we can use language or chemistry to try to sort of think about how we can make people, you know, be open-minded, get along better, make better decisions. Yeah.
Right. All right. Do you think the medium of poetry has sort of enabled you to cross certain activation barriers in terms of connecting with different kinds of people with different backgrounds and different experiences? Has vis-a-vis as compared to, you know, when you talk to people in various different social contexts. So do you think poetry has, you know, sort of enabled you to overcome these activation barriers?
Absolutely. It's been a real good catalyst in that way. It's lowered the barrier. Yeah, I would say it's really, when I was part of a poetry troupe, just interacting with and being part of that community and getting to see sort of how they think through things and their perspective on how they write poems and how they view the world. You know, I think there is there really is an artificial divide in society between sort of scientists and artists, or scientists and humanists, and I think it's really we're doing ourselves a disservice, and because the more perspectives we can bring in to think through a problem, and the more kinds of people we can interact with, we just have a much fuller understanding. We've only broadened our understanding of problems, and concepts, and broaden the approaches that we can take to solve things. So I really have learned a lot through interacting with not just the poetry community, but the science communication community. I think the things that you and others are doing are just really important. It's really important work because, again, people, especially nowadays, people see scientists as sort of other, right? The general public is not, and they view scientists with skepticism, especially now, you know, with so many big decisions depending on really good trust between scientists and the general population. I think that the importance of communication and clear communication and making things relatable and understand, humanizing what scientists do, making it sort of understandable is really, really important.
No, I think the aspect of building trust with different kinds of communities and stakeholders, that's a very, very important goal for all kinds and all forms of science communication. So I think that's a very valid point. Okay, so we sort of moving towards the end. So let me ask you about your process of writing poetry and how has your craft of writing poetry evolved? And would you have any suggestions for people, scientists, teachers, students, anyone just trying to, sort of starting off in poetry?
Yeah, that's a great question. So I'm a lifelong learner at this, so I'm just going to talk from personal experience, but I can't say that first of all, there's no one way to write a poem. And that's what I think is the most beautiful aspect of poetry is it is personal, right? It's everybody will see, let's say you are all looking at the same video, say with the sugar cube dissolving in water, and everybody's going to come up with something totally different to describe it. That's what makes it so amazing, right? It's very personal. But I would say, write what you know. In my case, it started from the stories that I would tell in prose. Right? I was like, how can I turn some of these into verse so that it's a little more, fun and memorable, perhaps? Sometimes an entire poem will start from a rhyme, especially these short couplets. Sometimes they're just inspired by a rhyme. Sometimes they're inspired by an analogy or a metaphor, and then I spend a lot of time trying to find a good rhyme. And there are some great resources, by the way, online for helping to find words that rhyme with other words. So this is something that I now am very familiar with trying to do. Because for me, I like rhyming poetry, but I also have written non-rhyming poetry. I think, again, it's something that you should feel free to just keep writing and persevere and write what you know. This is an old saying that really rings true. I know chemistry, so I write about it, right? And there's no limit to the kinds of things that you can write poetry about. And so I guess, yeah, and have other people read it. Don't be shy, read it out loud, read it to others, share your poetry. It's a very inclusive medium, like I said, because everybody's voice is unique. So yeah, and have fun with it.
Great, thanks for that. Would you have any message for scientists who are contemplating about writing poetry or if scientists are not contemplating why they should write poetry? So any message for your fellow scientists that they should start writing poetry?
Oh, I think you should. I'm all for, writing poetry and, again, personalizing science, however you want to do it. I think if we're all more honest about just how the ups and downs of doing science are, it's amazing to me. So I'm at a liberal arts college where I have the opportunity to hear people from all different sorts of fields. And it always amazes me when I go to talks that are given by famous humanists or famous authors, fiction writers, how they are talking a lot about themselves and their own journeys and what they did to write the book, or, how they brought themselves into the book. When you go to a scientific talk, no one ever talks about their own journey. They're just talking about the science and what the data show and, what the statistics are, which is important. You have to do that. But I think having almost a companion piece, even if it's a poem or a paragraph or something, about your personal story with it. How did you feel when the equipment broke, or how did you feel when you got this aha moment, or where were you? Were you eating dinner one day and it just popped into your head? So that humanizing the process of doing science is something that I'm growing increasingly passionate about, because I think it's really important for people, especially graduate students, for people who are going through the long journey of training, to know that this is, it's an emotional process, and writing about it can help, help people sort of, I don't know, validate that, right? It can help them feel better about it. It can help, get it out there and make it clear that everybody feels when doing science.
Great. I just want to add that if anybody is considering writing poetry, just take the plunge. And the rules of writing poetry are pretty flexible. You can play around. You can take a lot of creative license. So don't really worry about getting the specifics right. Just take the plunge, right? So I want to pick up on something you said, Mala, about your liberal arts education. Do you have any comments on why we should incorporate humanities subjects in scientific training, in whether at the graduate, undergraduate, or higher levels?
Oh, yes. I mean, I do. There's so many reasons why. I think I think that right now, understanding, especially now, humanities and social sciences, these disciplines um, are an integral part of being a scientist, in the sense that we need to understand where we came from. We need to understand that science as a discipline, even our models, the way we interpret them, they're fraught with bias. And what I mean by that is bias because of our own personal experiences, biases because we're human, biases because of sort of maybe the particular, populations that were studied and different kinds of, so all these things we need to think about them and to make us better scientists. Even the models that we come up, that might be models based in physics, those might actually be, they're a result of us, right, and our society, because we came up with them. And so I actually am teaching a course in the fall all about modeling across the disciplines. What are models? And what's fascinating is that models are fictional, right? They're things we come up with. So in some sense, there is a lot of similarity between someone who writes a novel, let's say a fictional novel, but it's based on reality. So a fictional novel about a family that has certain ties, or a science fiction novel based on something, or a book like 1984, right? These books are telling you something about ourselves through a model, which is the fiction, right? We're learning truths about the world around us through us, and that's no different than science, right? We come up with a model, like a Lewis structure model for drawing a molecule. It's not real, right? It's something we came up with. It represents the reality, and we use that to learn about the world around us. So in some sense, there are huge parallels between the arts and the humanities. When an artist does something, it is literally a model, and from that we're supposed to learn something about, maybe they're making a statement about something, and we're using that as a model to be able to use to learn something about us and ourselves. So so I really think that those perspectives are incredibly valuable, and also because you can be an amazing scientist but a horrible communicator. So I think we need to also work on having scientists communicate not just to other scientists, but to everybody, so that everybody can be informed citizens and everybody can also engage actively with science and be excited by it, because it's really, really a lot of fun.
Yeah, I just want to add that even within the teaching of science or science pedagogy, there's a huge scope for incorporating the process of science or the history and philosophy of science while you're teaching. So if you teach science using stories of scientists and how things were discovered or invented, there's a huge scope for sort of humanizing science, as you were saying rightly before, right? So I just wanted to add that point. All right. So I think we are sort of, we have around another 15 minutes left. Mala, should we have another recital and then we can move on to the audience questions?
Sure. So I'll read one more poem from, let me see if I can find it here, from my first book. And this is about the ideal gas law. So the ideal gas law is the idea that most gases, typical gases, sort of obey it. It's a model. And it describes how when you heat up, the basic idea is that's going on in this poem is, if you take a closed container and you heat it up, it will eventually explode. Because when you increase the temperature of a gas, it will expand, or the pressure will increase if you don't let it expand. So the pressure will increase and eventually break whatever container you're in. So you should never ever heat up a sealed container containing gas. This is called No One Can Stop Her. And stopper is spelled S-T-O-P-P-E-R, as in a stopper that you put on a test tube. There's one thing my buddies and I can agree on, that life's pretty good as an atom of neon. No pining for love, no reason to flirt, because loners we are, completely inert. And my name is Ned, a magnificent neon, been bouncing about in this box for an eon. The forces between us we barely can feel, so a gas of our atoms is nearly ideal. There's only one rule that we've clearly made known. Don't mess with this gas, just leave us alone. If you push us too far, you will certainly see the power of PV equals nRT. That's the ideal gas law. And by the way, P stands for pressure. Just have to interrupt the poem for a little bit. V stands for volume, and T is temperature. R is a constant and N is the number of moles or how much gas you have. One day we were forced to impose this one rule after, pardon the pun, we had lost our cool. I'll tell you the awfully painful story, beware, as the details are rather gory. Long, long ago, we would peacefully roam in a luxury test tube. She was our home. 'Twas roomy with crystal clear views, and atop her was placed a tightly fit rubber stopper. Now life was serene. We had nothing to fear, as our pressure inside was 1 atmosphere, and the size of our home, few others could beat her, a spacious 100 milliliters. Incidentally, we easily saw that thanks to the ideal gas law, 'twas true at 298K.004 moles of us lived there that day. But anyway, there we were living our lives when a girl with a Bunsen burner arrived, and the next thing we knew, its flame turned blue. We were heated so fast we didn't know what to do. So we bounced all around with a newly found ardor. Each time we hit glass, we now hit it much harder. Our collisions with glass were all nearly elastic, so the change in momentum was rather fantastic. From a human's perspective, this translates to a measure of a really enormous increase in the pressure. But you don't need a microscope's view to agree. You just need PV equals nRT. See, the heat invaded the test tube and our gas wasn't given the right to expand. Our T was increased. And to keep the equation, the V couldn't change, so the P saw inflation. The pressure built up so severely, in fact, that before the poor girl had some time to react, crack, we pushed on the glass till it burst. That day will live on in my mind as the worst. By our beautiful home were we quickly bereaved, as the difference in pressure was swiftly relieved, because we quickly expanded without an obstruction. But as we flew out, we surveyed the destruction. Shards of our home flew toward nearby lasses who weren't wearing their safety glasses. The problem was thus exacerbated. From all of our friends were we separated. To imagine the graphic events makes me and my friends is a real no-brainer.
Great. Thank you for that. I think we should move on to audience questions. So I see there's one question from Chandrakant. So Chandrakant asks, do you think a general poetry slam audience would be open to listening to and attending entire shows and gigs that were focused around science poetry?
That's a really good question. I would say based on my experiences, yes. I haven't done science poetry as part of long shows. I mean, not except by myself. There's one of my colleagues and friends writes physics limericks. So sometimes I remember one time we did like a dual open mic thing, and it was really fun at one of the bars. But I think so, because I find that the reactions that I get at with everyday crowds are quite positive. So I would have to say that would be a really fun thing. I would love to participate in that event. When I was really doing the poetry circuit, there wasn't a whole lot of other science poets out there. Now I think there are getting to be more and more and more. So I would love to work with them and sort of create some sort of, larger show. And I think it would be really useful and fun.
Cool. Right. So would anybody in the audience like to ask a question to Mala? You can type in your question in the chat box or raise your hands. Cool. So while we're waiting for questions, Mala, would you like to read out some of the contributions that we got on social media in response to the prompt that you had shared of a sugar cube dissolving in water?
Sure.
They're in the chat box.
Yes, I see one. Okay, so this is from Charu Steph, who sent this poem on Twitter. It's called Flirting 101. So this is in response to a video that we showed, just to give the background, where we had a sugar cube, and you will kind of watch the process of it slowly dissolving in water, and eventually it gets stirred. Sugar's hitting on water, saying, like dissolves like, that's why you fall for salt. I may not be ionic, but my popularity is more luring than alcohol. Let me crawl into your spaces. Let's bond via hydrogen, me and you, a flavorful existence. We could be a solution, true. Be my soulmate solvent, will you? And I'll be your sweet, sweet solute. I really like the I may not be ionic, but my popular is more alluring than alkyl. This is really good. I like it when the chemistry is also, for me, being chemically accurate is really, really important when I'm trying to write the poem. So I really appreciate
There's another one from Nosheen, I think. Right.
Yes. Okay. Nasheen. I sugar you. Okay. Thought my sweetness could rub off on you, thought I could break all your solid and physical states, thought you were less dense and I dived into you, but who knew? Who knew you can break my bonds? Who knew I would sing Miley's Wrecking Ball song for you? Losing my sanity, I dissolved into you with my energy gone, but I still gave up my sweetness to you.
And there's one by Anjana herself, so maybe you could read that out too.
Oh.
Just above Nosheen's comment.
Let's see. Do I see it here?
I'll just paste it below.
Okay. Casual. You have no character, too fluid and neutral, and you're too sweet, too polished and toxic. This will never work. We have no chemistry, but there's energy and it's purely physical. So that's getting at the fact that dissolving is considered a physical change as opposed to a chemical change, which is cool.
Right. If you don't have any more questions, all right. So I think I'm going to read out something by J.J. Thomson that I found earlier today, and it's really interesting. So I'm just going to read it out. So it's called Iron's Mind by J.J. Thomson, who was the person who discovered the electron. In the dusty laboratory, mid the coils and the wax and the twine, there the atoms in their glory ionize and recombine. Oh my darlings, oh my darlings, oh my darling iron's mine, you are lost and gone forever when just once you recombine. Right. Cool. I also found something that you've written, Mala, in your book, very interesting, which says about poetry and chemistry, which is the constraints within chemistry are like those in verse. They're usually a blessing, occasionally a curse. Would you like to tell us more about when they've been a curse?
Yeah, certainly in poetry, I do feel sometimes very constrained by the two-line thing that I now have set up. So I'm probably, whatever I do next will involve longer forms because like in my first book, having the space, rhymes are also highly constraining and rhythm especially. And I would say for me, getting rhythm right has been a bigger challenge. It definitely requires me to have other people read my poems back to me so I can hear, ooh, that's not, the syllable that I meant to have accented, or that's not how I meant it to sound. Or, and certainly that's something that I was not, when I go back and read some of my old poems, especially for my first book, sometimes like, oh, that rhythm is not as good. So I'm still honing that. So the constraints can be, you can look at them as a curse, but you can also look at them as a blessing, because for me, that structure is really useful. Sometimes it helps to have a structure because otherwise it's just too limitless, right? If someone just says, write something, but they don't give you a structure, it can sometimes feel overwhelming. So I prefer having a structure where it's like, okay, 2 couplets, tetrameter, rhyming, like go. Some people work well with structure, some people prefer no structure. But that's why, again, poetry is really wonderful in that it can support either of those.
Great. Chandrakant is asking you, as performance poetry in the slam sense is very close to storytelling, how far would a good slam poet be able to take the art form in teaching a lesson or giving a lecture? Could it replace the PowerPoint video as being the central mode of communication in a scientific presentation, as opposed to a fun add-on?
That's a great question. I mean, I think there's a lot of room for improvement in general scientific presentations. When I mean that, I mean at conferences and things like that. It is very standard. You stand next to your slides and you show them. So I think having an element, again, a bad pun sort of, but this element of poetry in sort of these scientific talks, or an element of performance almost, would be good in a certain sense, but you have to be careful because it's a cultural thing, right? You have to, the science has got to be good first and foremost, right? I mean, in a scientific talk. But oftentimes I think you lose half the audience. And these are audiences of the scientists, PhD level scientists too, but half of them are lost because speakers at many conferences don't take the time or put in the effort to make it relatable. So I do think having an element of sort of a catalytic element, whether it's a poem or an analogy or some sort of way to make it relatable for the audience, so that everybody can be sort of then bought in to the point where they're really paying attention to the slides, following the person all the way out throughout is good. And I think that a speaker should return to that kind of style or analogies or poems or some sort of element of storytelling often to keep people engaged, because sometimes talks at the conferences, are like an hour. And that's a long time to keep someone's attention, especially about something that can be very hard to understand and follow otherwise.
Right. So Aparajita Agarwal has posted on Facebook that I wish the books were available on Kindle. I'm really keen on reading the books in their entirety. The poems are hilarious.
Oh, thank you. Yeah, we are working on that. I had some, my illustrator and I tried to make ebook versions, and we're currently running into technical difficulties with the formatting because of the way they're placed on the page. So I'm in my copious spare time right now. I'm going to try to see if I can, get that to work, because I agree it's I would really like to make it more widely available and more efficiently available for as many people as possible. So I will try to speed that process along.
Right. Anjana Suresh is asking, did you ever have trouble seeing yourself as a real poet because of your scientific background and vice versa?
Yeah, that's a really good question. And the answer is 100% yes. If you ask me if I'm a poet, I still really have trouble answering that question. Because I don't, in some sense, you're right. It's a very cultural thing, right? It's hard to identify with one or the other. But in that sense, I think it's a question of sort of the imposter syndrome kind of thing that, people hear about. But I think it is hard to be, I have so much respect for people who I guess are poets by training, right? Who really have a sense of how to, create imagery or create, beautiful rhythm or rhyme or write free verse or whatever it is, or unrhymed, narrative or slam poems. And I still haven't put in, my whole 100% into poetry, right? So I do agree that I feel like I have a hard time calling myself a poet. And as for your other question, I think there is some pushback from the scientific community to use everyday language to describe science. People sometimes feel like you're dumbing it down, if you use, everyday language or you don't use the lingo. And I think that that's something we need to really push back against, because I consider myself pretty rigorous when it comes with the concepts, and certainly the science that I publish in scientific journals, is I'm a physical chemist by training, and I know those concepts very deeply. But I actually think that it solidifies our understanding to have multiple ways of thinking about it. So to be able to both use the scientific lingo, but also use the everyday lingo or poetic language to describe it, I think it's only going to make things better. So it's a really good question.
Right. So Anjana asks, what do you read? Who is a must-read poet according to you? Someone who deserves a lot more attention / readership than they're getting.
Oh, that's a really good question. So if you want to know someone that I'm just actually amazed by his ability to actually just combine very, very, very constrained thinking and poetry, is someone actually on Twitter named Anthony Etherin, Etherin. He does these palindromic, there's so many constraints, like palindromic haiku or palindromic sonnets, or anagram things. There's just so many constraints, and the way that someone can work within so many constraints and still come up with a poem with that makes sense is pretty amazing to me. So I would recommend him as far as poems. As far as science poetry, I was really inspired by a former Nobel Prize winner, Roald Hoffman. So he actually writes poetry. He has a couple of books out. And so it's Hoffmann. And it's not, his poetry is not really pedagogical in nature, but it really brings elements of science into what he does. And then finally, I find Alan Lightman's work incredibly inspirational. He's not a poet, but he is a science, he writes fiction and also nonfiction that brings science in. And my favorite book by him, so he wrote Einstein's Dreams, which is what he's most known for. And it's sort of how different ways time could be, like cyclical or, nonlinear, or all these different sort of telling stories through different ways that you could think of time sort of existing that were different than how it actually is. But my favorite book by him is a collection of essays called Dance for Two, which there's one particular essay that he talks about humanizing science, which I think really spoke to me. And so again, his name is Alan Lightman, Lightman.
Thanks. I think we're almost nearing the end. So this is the last question that I'm going to be posing to you. So Chandrakant once again asked, great lecturers are usually great performers. They incorporate a lot of tricks in their performance poetry. Is there any space or organized movement where scientists or presenters can see themselves as performers, at least to improve their own presentation, which I think will be very beneficial for them?
That's a great question. I almost want to turn that back to you, Siddharth, because I know you actually, this is one thing that I think you're keen on, and you actually talk about. I will just say from personal experience that, enthusiasm is contagious. And that's one thing that my students have remarked on. I really enjoy science. I genuinely like it. And I think being honest when you present, if you're excited about something, then just be excited, and you don't have to worry about, is this going to look professional? Because I think we are professional scientists, and it's important to be excited about what we do. And so that's one thing that I think every science presentation should bring into, is this feeling of excitement for what we're doing. But I'm wondering if, as far as more sort of technical things, maybe Siddharth, you might have things to say about that.
I think, what you said is, of course, I agree with that. I don't know of any space or organized movement, at least in India, where scientists especially can come and perform. But I think with the digital era, I think anything's possible. So you could, really start off a live broadcast on Twitter or YouTube or Facebook, and then there's always people, So I think community building, or where one can explore and experiment, is very important. So I know that Chandrakant, who's asked this question himself, runs a poetry collective called Bullock Cut Poetry. So maybe that's a place where you could get together and do some things. I also run a club where we sort of discuss the science of science communication, and I would be really happy to discuss this further with anyone. So, but for now, I don't really have anything to say in terms of spaces where people could do this. But I think it's really important for people to sort of come together and learn from each other. So I think that community aspect of also not just scientists, but also people from all different kinds of backgrounds, expertise, values, and interest. I think there's great value in bringing them together and sort of having a dialogue and conversation with them. So I think we're out of time. So with that, I would like to conclude the session and thank Mala once again. So over to you, the IIHS team. Thank you so much, Mala.
Thank you. Thank you.
Thank you so much, both of you. You're right, enthusiasm is extremely contagious, and more power to your enthusiasm for using deep concepts and simple words. And we hope that you continue writing, and till Mala's works are more widely available, do share this video so that people can enjoy her poetry as much as all of us have. Thank you once again. This has been a really great session. And thank you to everyone who joined us this evening. Do follow the IHS social media handles on Facebook, Twitter, and Instagram, or register with us to find out about our next public text session. The registration link is in your chat box. Thank you, everyone. Have a good evening.